Rotations, ma'am.
Yeah. What kind of rotations we have seen? What are the types of rotations we have seen?
Left
Right,
rotation,
left
right rotation,
Very
right,
good.
left, right,
Okay.
rotation,
right,
right,
left.
left rotation.
Very good. So these different types of rotation we have seen. That is why we need rotation. Why we need rotation? Anyone can justify? What is the purpose of rotation?
Balancing the search tree.
Exactly. Very good. We have to balance the binary search tree, right? So if we balance the binary search tree, that binary search tree will become what?
AVL.
Exactly. Good. So
Balanced binary search
yes,
tree.
balanced binary search tree, nothing but AVL trees, right?
AVL.
So why we have to have this AVL trees means binary search tree is a very good idea of searching elements where frequent insertion deletion happening. In that kind of time, we can use binary search tree. But there is a chance that skewed tree type, because there is a chance of growing only one side of tree whereas another side is not growing much, so again it becomes inefficient in that case. So what we have to do, we trying to do balance the tree when each and every element getting inserted. But this rotation takes again much more complexity, correct? So where frequent insertion deletion happening, we can't use that time AVL trees. Okay, where frequent insertion deletion, it is it is again inefficient to AVL trees. For example, when when searching is frequent whereas insertion is not frequent, that time we can use this AVL kind of trees. Okay, for example, a number of trains, maybe train data they are storing. Okay, new train may be introduced every 1 year, or it is maybe a long gap, correct? But searching a train details is frequent, so that time to maintain that kind of details they can use AVL trees where insertion is not frequent, where searching is frequent. That time we can use AVL trees. Okay guys, yes, isn't it understood?
Yes,
Others can also
Yes, ma'am.
reply.
Yes,
Okay
yes,
guys,
ma'am.
so yesterday we have seen four types of rotations, correct? Left rotation, right rotation, left right rotation, and right left rotation, correct?
Yes,
See,
ma'am.
this is what example, that is where we can have left left pattern, correct? Left left pattern means what you have to do, what you have to do,
right rotation.
exactly right rotation. See, in exam you can use this kind of structure to explain. See, root, and then you're checking, this can be subtrees, this can be anything, correct? This can be any subtree. It is not that there can be only one node, it is not like that, this can be any subtree. Okay, and then this is root node, one child node, and I can have any subtrees like this. And here I'm inserting new, that time I can have left left, so I'm doing right rotation, I can get this architecture. The same they explained with one example. This is what we have seen yesterday. Left left architecture, I'm just rotating right so that I can get this balanced tree. Yes, yesterday we have seen this only, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. Okay. Now another example where we can have right possibility. We have to rotate left so that that time we can get balanced tree. Okay. So the equivalent architecture how we can give. See, this is root node where I can have right possibility. So I have to rotate left. Okay. So whatever the subtree, it remains same. I'm not going to touch anything. I'm completely rotating that subtree to the right. So this is the example I can get like this. Is it fine guys? Okay guys, are you getting?
Yes, ma'am.
Yes,
Ah,
ma'am.
yeah.
Yes, ma'am.
See here one more thing you can notice here, and I will explain in previous example here also. See, I'm just inserting new node here, correct? I'm inserting new node. So which node will become unbalanced? This is 0, this is 1, this is also 1, but this is But this node, what?
2, ma'am.
2. Good.
2.
2, right? Okay. So that time, Sanniraj,
Yes, ma'am.
take a snap, ma,
Okay, ma'am.
because we should not wait still. Just take a full screen snap. Okay. And have a look deeply. So this is the node where this is the node violating the balancing property. So what you have to do, down 2 level you're checking, correct? This is left and also this is left. So what you have to do, guys, what you have to do, you have
Right
to do
rotation.
exactly
Right.
right rotation. So you are rotating right, so that just rotating right, but check that this left subtree, I'm sorry, right subtree, check this right subtree where it is getting. Any difference you are getting? You are getting? Or shall we see
Yes,
with one
ma'am.
example? See, yesterday we have seen, right, same thing. See here, left, left. I am doing the right rotation. You just ignore this as now. I am doing right rotation. So C will become root node, and then C will become root node, or will come down, then T3 it will join as usual. But just think about this T2 where it have joined. Understood why we added there? Guys, is it clear why we added there? So this is the architecture, you have to remind carefully. If there is any right subtree here, so where you have to add? Where you have to add after rotating, you have to add to the left of this where your root node become again subtree, no? There in that place you have to add. Shall we see with an example?
Yes, ma'am.
But yesterday's thing, everything is clear, right? Yesterday's thing, everything is clear.
Yes,
Yes,
ma'am.
Yes, ma'am.
Okay, but we have seen only simple example like this, correct? Only 3 nodes we have seen, and there is no any other subtree. So it was very clear. See, the rotation is performed after new element is inserted into the left subtree, where we are inserting an element into the left subtree of the left child of the tree, correct? You are inserting left subtree and left child, correct? So definitely the root have become imbalanced. That time you have to do rotation. We will see with an example again, with big example, so that you will understand better. But whatever we have seen yesterday with small example, is it clear? As this one is clear, very clear with small example.
yes, ma'am.
Okay, okay. And that attaching thing I will explain again with a big example with many numbers, so that you will understand. But you should keep in your mind where we are inserting. See, I am just rotating. See, if there is no T2, no issues at all, correct? If there is no T2, no issues at all. I am just rotating. So C will become root node. It will completely will come down. But what can I do with T2? So where I am joining, I am just inserting into left side of this node. So with example only you will understand better. We will see next. So this also we have seen where we have to do left rotation. Okay. This example you understood, right? This one what I explained yesterday, you understood, everyone? Here I'm having
Yes,
right,
ma'am.
here I'm having right. So I have to do left rotation. I'm doing. So I got balanced. But whereas in real time, it is not at only one node. I can have many subtrees, correct? Where I'm inserting right side and right side node, right side subtree where I'm inserting. So I have to do left rotation. So how I can do left rotation? So again, C will become root node and R is coming down. T1 as usual I will be adding. But what happened to T2? Where I'm inserting in the left side. Okay. Subtree I'm inserting left side. Don't worry, we will see with an example. Just keep in mind. Okay. But just understand this basic concept. Okay. Next we'll see with example. And one more what we have seen where we need 2 rotation. Correct. 2 rotation means, see here. Okay, this may confuse you. Yeah, yesterday we have seen this kind of example, right? Where we need L, R. So from bottom to up, you have to do first you are doing left rotation and then right rotation, so that you can get the balanced tree like this. Where this is also one more type of rotation where you can have right, left. So from bottom up, you have to do right first and then you have to do left rotation. Guys, all these four, is it clear? All these four?
Yes, ma'am.
Guys,
Yes,
everyone
ma'am.
answer me, no? Everyone answer me. All four types of rotation?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
Guys, who on
Yes,
the
ma'am.
left, who on the left out, can you tell? Who on the numbers left out, can you tell? I'll just note it down. What are the numbers left out? USN? Just scan and let me know. Someone can help me. Mute yourself so that it is easy. Number 3 and then?
Ma'am, 12.
12, okay.
Oh, no, ma'am.
What happened?
12 is there, ma'am.
Please, sir, ma'am.
Okay, 13, 14 and then? 17, 19. So for these number, Adnan should not be given. $36, 40. Ranjit Kumar, can't you insert your USN? Huh? Ranjit Kumar, you are there? Okay, guys. Who is 17? Who's number 17? Guys, who is number 17? Any idea? Okay, I will check myself. No issues. So these numbers I won't give attendance.
I think Rajnikant, ma'am.
Okay, ma. Okay. Thank you. Okay. So now we will see with one example. That is a big example. So same example in our book we will take. Okay. Now I'm going to. We try to construct on AVL trees with numbers. Everyone could see this paint screen?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now I'm going to construct. These are the numbers. Okay. These are the different numbers. I have to construct AVL tree for that. Okay. Let me start. So what is the first number I have to insert? What is the first number? I'm inserting. Guys, answer me. 1. Okay.
1.
Yes. So there is no issues because only one element. So what is the next element I'm going to insert?
2.
Where I
2.
have to insert? Where I have to insert? Because it is obviously
Right
binary
of
search
1.
tree. Exactly. So right side I have to insert.
Right, sir.
2. So again I have to check the balancing factor. Any issues in it? Is any issues in it?
No, ma'am.
Because it is 1, it is 0. No
Oh.
issues. And 3. Where I have to insert 3?
Right side
Right
of
of 2.
Very good. Right side of 2. Here I have to insert. Any issues in it? Just check. Any issues in it? Just check.
Yes, ma'am. In
Minus
1.
2.
So we will check again. What is the balancing factor?
0.
0. And what about
0.
here?
minus
Minus 1.
1.
Minus 1. Very good.
Minus 1.
Here?
Minus 2.
Minus
minus 2.
Minus?
2.
Very good.
2.
So,
Minus
guys, if you didn't listen yesterday, at least listen now. Okay, answer me so that you will understand Okay, so where is the problem? Which node violating the rule? The number
One.
1 violating the rule. So what we have to do? From that node, I have to check 2 levels down. 1 level.
Right.
So this is what? Right pattern. This is
Right.
also what? Right
Right.
pattern.
Right
So
pattern.
if I have right and right, I have to do RR means I have to do left rotation.
Left rotation.
That is which node
L.
violating rule? I have to rotate that node left side. So how this will become?
Two
How
will
this will
become the root
become?
node.
Two.
Two
Two
will
will be
become the root.
Exactly. 2 will become
Root.
Root node.
root node, and then
One become the left.
2 will become root node. Very good. 1 will become left. Very good. And
Left
then
side.
Three become the right.
Is
Become
very
right
good. 3
side.
become right. Good. So I'm just joining everything. Okay. Now we will check the balance. This is also 0. Correct. This is also 0. And then
This is also 0.
0. 3 also 0. Now it is proper AVL tree. Yes, we will move
yes,
on.
ma'am.
Okay,
Yes.
we will move to next step. What is the next element? What is the next
Four.
element I have to
4.
insert? 4. Where I should insert? Where I should
Right side
insert?
of
of
3.
three.
Right side of 4. I mean 3.
Yeah,
Right side of
right side of 3. Very good. I'm just inserting right side of 3. You just check any problem I'm getting, any problem I'm getting, any imbalance,
No, ma'am.
any
No.
imbalance. So we will check. What about the balancing factor 4? What about balancing factor?
0.
0.
What about 3?
Minus
Minus
1.
1.
Very good. What about 1?
1.
0.
1.
What about 2?
Minus 1.
Very good.
Minus 1.
So it is perfect. What is the next element I should insert? What is the next element I should
5.
insert?
5.
5. Where I should insert? Where I should insert?
Right side of 4.
Right
Right
of
side
4.
of 4.
Very good.
Side
Right
of
side of 4. I'm inserting 5 here. Just check any other element violating the property, balancing property.
Yes, ma'am.
We will check.
Yes.
So this is
Ma'am.
0. This is
0.
minus 1.
Minus
This is
1.
minus
Minus
2.
2. Minus 2.
This is also minus
Minus 2.
Minus 2.
Minus
This
2.
is 0. So from
0.
bottom up, we are checking this node is violating rules. So what
3.
you have to do? Down 2 level, I'm checking.
3.
This is also right. This is also right. So what I should do? So
Left.
Left
just
rotation.
consider
shift.
only
Rotation.
these 3 elements. Okay, like as such. You just don't bother about these. Finally, you can add as such. So I'm just doing left rotation because this is right. This is right. I'm just doing left rotation. So what will happen? 4 will become root node. 3 will
Root
become
node.
left side, and 5 will become the
Left side.
right subtree. Correct.
Yes,
Okay.
ma'am.
Can I redo it here itself? Yes, fine, guys.
Yes. Okay.
Yes, ma'am.
You just keep in mind which one will come there, which one will come left.
3 will be in root.
Okay, so no, 4 will be the root. No,
Yes,
Yes,
ma'am.
4 will come here, and then
3 left node.
Will be 3 and right will be 5.
exactly.
Hmm. Yes.
So 3 will come here, and 5 will go here. Shall we check again the balancing factor?
Yes, ma'am.
This is 0. For 5 also it is 0, and then what about 4? What about 4?
0. 0.
0.
And what about 1?
0.
0.
0.
Okay, and then what about 2?
Minus 1.
Minus 1.
Okay, so now understood. So no need of rotation again. So what is the next element we have to insert? What is the next element we have to insert?
6.
6.
Number 6. Correct. So number 6, where I should insert? Where I should
Right
Right
side
of
of
5.
Side of 6.
Very good. Right side of 5. Okay. So I'm just checking what any other rule violating. Just check which rule, which node violating the rule. So this is 0. This is minus 1. This is also 0. This is minus 1.
Minus
This is also 0. Here it is minus
minus 2.
2.
2.
So I'm just checking. This is violating rule. So I'm just checking down 2 places. That is nothing but left. So I'm sorry, right, right. So what you have to do? Right, right. What you have to do? You have to do
Left
left
rotation.
rotation. Just imagine only these nodes, because this is what we are going to do rotation. Correct, guys? Yes, this is what we
Yes,
are going to do
ma'am.
rotation. What rotation we have to do? What rotation we have to do?
Rotation.
We have to do
Left rotation.
very good, very good. We have to do left rotation. So what will happen? 4 will become
Root node.
Root node.
what about 2?
Left node.
Left node. And what about 5?
Left side.
Right.
Right side.
Very good. So I'm just rewriting. See, you just as now you don't just ignore these elements. So what you told, 4 will become root node. And just so you only told 4 will become root node, 2 will become left, and then 5 will become right. Correct. So I am just writing. See, I had put like this. I had put like this. What are the numbers? 4 will become root node, 2 will become left, and then 5 will become right. Correct.
3.
Okay. So we'll just insert other elements. So 1 is what? 1 is what? Left of 2. Correct.
2.
So I have to insert 1. And 6 is what? Right of 5. I have to insert. Correct. Yes, I'm just inserting. I'm just inserting the elements. That is what? 1. And here 6. Now where you should put this 3?
3.
Where you should put this 3?
Right up to.
Right side of 2.
Very good. So when I'm doing left rotation, this subtree, if any subtree, where I have to insert to this root node, to the where I am rotating node, to this node I have to attach. That means what? It should what? It should it should satisfy the BST property also. So 3 obviously where it will come? Definitely it will come left child. Correct. It should not violate BST property also. Correct, guys? So in that way also you can think 3 definitely where it will come. If 4 becomes root node, definitely 3 will come left side, and again where it will come, definitely right side of 2. Correct.
Right of 2.
Now understood. Now again I will go back to that. Again I will go back to our notes. I will show the notes now. Now check this. Now check this. This is the diagram I have shown you, right? Guys, yes, this is the diagram I've shown you. See here, right. So we have done left rotation. But where to insert this T2, we have a doubt. Where we inserted right of this root node. That is what we have done here. Now understood what is that diagram explaining?
Yes, ma'am.
Guys,
Yes, ma'am.
everyone have to open up. So
Yes, ma'am.
Yes, ma'am.
I have to insert 3 over here. So now whether it is binary search tree? Yes,
It's not visible, ma'am.
it is not visible.
No, ma'am.
1 minute.
ma'am.
No, ma'am.
You just check.
Yes,
Guys,
ma'am.
now,
Yes, ma'am.
yeah. Now
Yes, ma'am.
balancing factor 0, 0, 0. This is also 0. This is minus 1. And here 0. So whether it is BST, whether it is BST,
ma'am.
whether it is AVL,
Yes, ma'am.
very
Yes,
good,
ma'am.
proper. So what is the next node we have to insert now?
7.
7.
7. So where
7.
7 where it will go?
Right of 6.
Right side of 6.
Yes, right side of 6. Okay. So I'm just inserting 7 over here. Okay. So obviously where and all it will violate, it is 0. And then this node balancing factor 0, this node balancing factor -1, this node's balancing factor -2, and this node -1, and all these are 0, 0. So I have to consider here to level down. So these 3 elements I have to consider now. So I'm checking this pattern, right. So what I have to do? I have to do
Left rotation.
very
Left
good. So I
rotation.
have to do left rotation. So what will happen? 6 will become,
Root
Root
node.
node.
and 5 will become,
Left side.
Left node.
yeah, and 7 will become.
Right
Right
side.
node.
That's it. So I'm just keep in mind, guys. Okay. So what will happen? 6 will become,
Root
Root
node.
node.
and then here,
5.
and then here.
7.
Okay. Okay. Now check. Now check, guys. Is it fine? Whether it is binary search tree,
Yes, ma'am.
whether
Yes,
it is
ma'am.
AVL tree.
Yes, ma'am.
Yes. Okay. So we have done everything perfect, and we inserted all the elements. Okay. Just check how neatly we got AVL tree. So can anyone tell if it is simply binary tree, how the structure will be? If it is simply binary search tree, 1 I am inserting, and what will happen? 2 I am inserting, correct? 3 I am inserting, and 4 and 5, and like this only the tree will be, right?
Yes, ma'am.
Yes, ma'am.
See, but this is binary search tree, correct? No issues in it,
Yes,
correct?
ma'am.
This is proper. This is binary search tree. But if I want to search, I have to do kind of linear search. One by one I have to do. It is skewed. What is that? Left skewed tree. Only left side, right skewed tree. Only right side it is growing. So we need balanced, height balanced tree. So this is the equivalent AVL tree for the given numbers. Guys, understood how I made?
Yes, ma'am.
Okay. Shall we proceed with one more example? Answer me.
Yes, ma'am.
Yes, ma'am.
Okay. One more example we will see. Then I will give one problem. Okay. Is it visible, the elements? Elements visible?
Yes,
Yes,
ma'am.
ma'am.
What is the first element?
50.
50.
Okay. What is the second element?
25.
Where
25.
I should insert?
Left of 50.
Left of 50.
Very good. What about next element?
10.
10.
10, where I should insert?
Left of
Left of
25.
Left of 25.
As now no issues in height, and I'm inserting left of 10. I'm inserting here. Any balancing property problem? Any problem in property
ma'am.
violation? So what we have to do?
Yes.
This is 0, this is 1, this is 2. So this is the node violating property. I have to do. This is also
Right
left.
rotation.
It's also left, and I
Right.
have to do. I have
Right rotation.
do right rotation.
Right.
Do right rotation. So what is the resultant tree? What is the resultant tree?
25 root node.
Yes. So 25 will become root, and then
50 will become right node.
very good. 50 will become. Okay. What is the next step? What is the next
5.
step? 5. Where I should insert 5?
Left of 10.
Left of 10.
Left of 10. Okay. I'm just inserting 5 here. Is there any problem in any other node? Is there any problem in any other
No.
node? So no problem, right?
No, ma'am.
And what about next element?
7.
Where,
Seven, ma'am.
where you have to insert?
Right
Left
of
of
5.
Right of 5.
Very good. Right of 5. Just check any other problem. Check any other problem to any other node. What about this node?
Yes, ma'am.
What about height balance for 7? 0. What about height balancing factor for 5?
0.
Minus 1.
-1.
minus
What
1.
about
1.
it is 2? What about
2.
50? 0. What
0.
about
0.
25? This is 2. Correct. So which
Yes,
node
ma'am.
violating? From bottom up I'm checking. So this node is violating.
10.
What I have to do? I have to see from that down I'm checking. What is that? This is left. This is right. Correct. That is
Right.
LR. LR means from bottom up I have to do. First this two I have to do. These two I have to do.
Left rotation.
Very good. These
Setting.
two I have to do left rotation. If I do left rotation, what will happen? Just imagine I'm just doing left rotation. What will happen? 5 will come down, 7 will go top. Correct.
Up.
So the
Yes, ma'am.
structure will be 10 and then 7 and then 5. Guys, everyone agree this step?
Yes, ma'am.
Guys,
Yes,
everyone agree
ma'am.
this step? Guys, everyone, please answer me. This is, you have to understand, else it is little difficult. Guys, is it clear? Everyone answer me.
Yes, ma'am.
Yes,
How
ma'am.
I wrote? Okay,
Yes,
very,
ma'am.
okay, guys, good. So again, which left I have to do? I have to do 2 rotation in this pattern. Left, and then I have to do,
Right.
because
rotation.
this node is violating, and then I have to do right rotation. So this step will become 7 will become root node, and then 5 will be here, and then 10 will be here. Is it clear this step?
Yes, ma'am.
So can I replace this place with this numbers? Yes. So
Ma'am.
7 is my root node, 5 is my
Yes,
left,
ma'am.
and 10 is my right. Can I replace?
Yes, ma'am.
Yes, ma'am.
Ma'am.
I'm just replacing with that. What will happen? What will happen? Just so which node will come here? Which is the root
7.
node? Very good.
7.
7. So 7 is my, and what
Root
about
node.
left child? What about left child?
5.
Very good. What
5.
about right child?
10.
10.
10.
Very good. So what is the next element I should insert? What is the next element I should insert?
3.
So 50 is done, 25, 10, 5, 7, everything is done. So 3. Where I should insert 3? Where I should insert 3?
Left of
Left of
5.
5.
Left of 5, right? So I have to insert 3. Just check any violation. Just check any violation at any node. 3 I am inserting. Any violation in any other node?
Yes, ma'am.
So which is the node violating our property?
25.
So this is 0, this is 1, this is 0. Obviously all leaf nodes are 0, correct? And this is 1, this is 0, but here 2. So 25 violating the property. So I'm just checking 2 places. So 2 down, these 2 down. So what is this? Left, left. So what I have to do? What I have to do?
Right rotation.
Very good. Right
Right
rotation.
rotation.
Just consider 25 and then 7 and then 5. If I do right rotation, what will happen? 7 will become root node
Root node.
and then 5 will become
Left side.
left. Very good.
Left.
And 25 will become
25 will become
Right
right.
side.
right side of 7. Can I replace with this structure here? Can I replace with this structure? So what will happen? 7 will become root node and then, yes, let me know.
5 will become. 5
5,
left
ma'am.
side.
Yeah. So 7 will become root node. 5 will become, and then what about right?
25.
25. And I'm just inserting 50 as such. I'm just inserting 50 as such. What about next? I'm just inserting 50 as such, and then and 3 I'm inserting as such. So 3 what is the next element? What is the next element?
10.
Okay. Now where I should insert 10? Where I should insert 10? Can anyone tell?
Left of 25.
Very good. Left side of 28. This is what that diagram explains. If any subtree, you have to include here. That's all. Understood, everyone? Yes?
Yes, ma'am.
This, okay. So now I will post one problem. You can continue this problem also. The same problem I am putting. You try to finish that. Okay, guys? Guys, is it fine? Still, how many elements you have to
Yes,
insert?
ma'am.
Still few more elements you have to insert. Okay, 30, 20, 8, 15. Try to insert. Okay. And if any doubt, we will discuss that.